Welcome to the project demonstration of solar integrated roofing system. So in this project we are going to use two solar panels. One is as a normal input and another is a boosting purpose. So this solar panel voltage will be input to the battery through the charging circuit directly and to the voltage sensor, and this is a voltage solar panel which we are using less ratings than the solar panel 1. So the solar panel 2 is input to the microcontroller through the boost converter. So here we are proving that the bigger solar panel voltage is getting some V voltage, but the smaller voltage solar panel will provide us the more than the voltage which is coming out from the solar panel 1. So that's the main purpose of this project. And the charging, the generator voltage is input to this battery through these two charging circuits, solar panel 1 and solar panel 2, and this is the charging circuit for the grid connection purpose. So whenever the sunlight is not available, if you want to charge a battery, then connect the transformer to the 230 volts input and connect this 2 pin at the TX slot on this charging circuit. So now the battery is charging through the transformer. So when you want to charge a battery either from the transformer or a solar panel 1 or solar panel 2, it will take 6 hours minimum, 8 hours maximum. If we connect the all together at a time, it will get fully charged in a duration of 2 hours only, as we are providing the more power. So here the power coming out from the solar panel 2 is 30 watts 12 volts, and this is the 40 watts 12 volts, and this is the 20 watts 230 volts and 12 volts transformer. Coming to the battery ratings, we are using 12 volt 5 amp battery pack, and this battery pack consists of 5 sub battery packs. So each sub battery pack consists of 3 4 volt 1 amp battery are in series, so we'll get 12 volt 1 amp. Like that, totally 5 amps of batteries are in parallel, so we'll get 12 volt 5 amp DC output directly. And here the loads we are using is, one is a fan, so which is 12 volts DC fan, and another is the inverting purpose, directly 200 watts of 230 volts inverter we are using. So 12 volts DC input to this inverting circuit, so which has the IC which can generate the pulses up to 50 hertz with the 12 volts. The 12 volts AC will be step up to the 230 volts AC with the help of this step up transformer. The output is input to the 3 pin sockets and 2 bulb holders directly. And coming to the microcontrol section, so which will take 12 volts DC input from the 12 volts battery, and there is a 7805 regulator which will take 12 volts input and provide us a 5 volts DC output. So when we provide that, it start reading input from the 2 voltage sensors, and the boost converter will be done with help of the solar panel voltage 2, and it will compare that, it will boost up the voltage. And here we are using one more concept is MPPT, maximum power point tracking. So when we are going to charge this battery, we need to provide 14.5 volts maximum. So if we provide more than that, the battery may get damaged. From this solar panel 1, the direct voltage is input to the battery section, and remaining voltage will be wasted. When the voltage is wasted, the power also wasted. Coming to this solar panel 2, the voltage will be regulated to 14.5 when we are getting the more than 14.5. Though we are using 12 volt solar panel, when we place this under full sunlight, we will get up to 27 or 21 volts maximum based on the solar panel ratings. So the remaining voltage will be wasted. In order to make the maximum power point tracking, we need to regulate the voltage to 14.5, then we'll get the more currents in order to maintain the 30 watts of power. Then we'll get the maximum power for the battery to charge that in less time compared to a normal solar panel or grid supply. So let us see the demonstration. So you can connect the load here. We can use 150 watts of load maximum on this, though we are using 200 watts. For safety purpose, don't use more than the 150 watts of load. Now we are using 100 watts bulb here directly. So it's 100 watts bulb, and connect the solar panel 1. So before switch on the power supply, make the connections first. So solar panel 1, and we need to connect the solar panel 1 at this charging slot, right? And solar panel 2 should be connected on this solar panel 2 slots. After the boosting is done, then the voltage will input to this charging circuit. So that's why it started slowly. Now after the connection is made successfully done, you can on the power supply, and you can off the inverter initially, right? So wait for the voltages input, right? So this is solar panel voltage which is from this solar panel 1, and solar panel 2 is boost voltage which is of 3.92 voltage. 2 volts is input from this one, and 3.92 voltage is coming out from the solar panel, small solar panel, after boosting was successfully done. Right, coming to the utilization. So if you want to on the fan, CPU fan, this is the switch for CPU fan, you can on that. And for the inverting purpose, this is switch we are going to use. Right.